Hi, my name is Elène Haave-audet, and I'm really excited to share with you the work that I've been conducting on individual differences in sampling behavior in black-capped chickadees with my supervisor, Dr. Kim Mathot at the University of Alberta. Individuals face uncertainty in virtually every decision they make, and uncertainty being the degree to which events are determined by factors that are out of an individual's knowledge. And there are different strategies that individuals can adopt to manage uncertainty. One of them being sampling, which reduces the likelihood of an uncertain, costly outcome. Now, sampling behavior is the regular exploitation of all the options of a particular resource, allowing individuals to gather information about the current state of those options and to avoid any if they are unprofitable. Now, models predict that sampling will take place under two sets of conditions. The first being sampling for survival, when the risk of starvation is high and individuals must sample out of necessity. Second, individuals might sample as a luxury, when the risk of starvation is low and they can invest in sampling. Now, given these two sets of conditions, we expect them to be related differently to survival. So, if there's a positive correlation between survival and sampling behavior, this means that individuals that are in a better state are the ones that are sampling more and are probably sampling as a luxury. Conversely, if there's a negative relationship between sampling and survival, then individuals in a poorer state are the ones that are sampling and are probably doing so out of necessity. However, if there is no correlation between sampling and survival, then this might be because at the level of the population, both sampling out of necessity and out of luxury are taking place, either because different individuals are experiencing different conditions or because individuals are able to adjust their sampling behavior to match the conditions that they're currently experiencing. So I'm studying sampling behavior in this beautiful and feisty bird, the black-capped chickadee, because they overwinter in harsh conditions where we expect that survival will be affected by sampling. Chickadees also readily visit bird feeders, making them conducive to studies where we manipulate food availability. And in our study, we define sampling behavior as taking place when an individual visited a resource patch that had previously been experienced in an unprofitable state. So today I'm going to specifically ask two questions. First, does sampling take place out of necessity or as a luxury in our population of black-capped chickadees? And second, does sampling behavior predict survival in this population? So our study was conducted at the University of Alberta Botanic Garden, which is located here on Treaty 6 territory, the traditional lands of First Nations and Métis people. And at these 8 sites depicted by the black dots in our study area, we set up 2 bird feeders, where we implemented 4 treatments that differed in food availability, replicated 4 times, which I'll explain in more detail shortly. The study was conducted in winter of 2019-2020, and I used redetection data from this past winter to assess survival 1 year following the end of the experiment. So this is our feeder setup here. Individuals were tagged with passive integrative transponder codes on their leg band, and feeders were equipped with radio frequency antenna that the birds needed to land on in order to access seeds, thus ensuring that individual visits were recorded. And that looks like this. So the experiment was laid out as follows. For the first 4 days, both feeders were full, ensuring that birds would come and use the resource we provided. Then we randomly emptied one of the 2 feeders at each of the 8 sites and measured sampling behavior at the empty feeder for 4 days. Then we switched food availability at the feeders and again measured sampling at the empty feeder. Finally, for 12 days, we emptied both feeders to ensure that we weren't inflating overwinter survival in the population by providing continuous food source. And in this case, we only measured sampling at the feeder that had been full in the previous treatment and for 4 days only to ensure consistency with the previous treatments. Now, when there was an alternative food source at the site, we considered sampling to be taking place in a state of luxury. And when there was no alternative at the site, we consider this to be sampling out of necessity. So in our population, the repeatability of sampling overall was 25%. So sampling behavior is also predicted to be affected by temperature differently whether sampling is occurring as a necessity or as a luxury. Specifically, when there are no alternative food sources, sampling behavior is expected to be highest when individuals are experiencing the most thermal stress at low temperatures. Conversely, when there is alternative food available and sampling is taking place as a luxury, we expect the opposite relationship, where the probability of sampling behavior increases as thermal stress decreases with increasing temperature. And that's exactly what we found in our study, that sampling as a luxury was positively correlated with temperature, while sampling out of necessity with no alternative food sources was negatively correlated with temperature. Now, in order to assess the among individual effects of sampling on survival, we measured the among individual correlations between the two types of sampling and survival. Now, recall that we predicted these relationships to be different based on the type of sampling taking place. Specifically, sampling as a necessity was expected to be negatively correlated with survival, and sampling as a luxury was expected to be positively correlated with survival. However, what we found was both of these traits were slightly positively associated with sampling behavior. Now, given this surprising result, we wanted to assess the relationship between the two types of sampling. Now, initially, we would have predicted that on average, individuals that sampled out of luxury would not have sampled as necessity. But given that the correlations with survival were the same, this might not be the case, which is exactly what we found. We found this surprising, strong, positive correlation between the two traits, meaning that on average, individuals that sampled more as a luxury also sampled more out of necessity. Now, this suggests that sampling is actually a single trait in our population, and this might be explained by the biology of chickadees. So chickadees forage in wintering flocks, meaning that individuals might not necessarily need to rely on personal information to assess the state of a resource. Specifically, those non-sampling individuals might actually be relying on social information, which might explain why we didn't see a strong positive relationship between sampling and survival. The credible intervals of that estimate overlap 0. Further, it was surprising that we could not detect differences in the different types of sampling behavior. And this might be because resource heterogeneity is quite high in our population, even though we manipulated food availability. That's because individuals cache in chickadees. So those individuals that sampled more perhaps are always experiencing a state of luxury because they have better caches than the individuals that don't sample. So these would be really interesting avenues for us to explore in our population to explain why it is that we're seeing that some individuals are sampling consistently more than others. So with that, I thank you very much for tuning in today, and I hope to see you later at the question period.